Alright, today we're talking about 5.2 congruent triangles. What you'll be learning about is how to identify the corresponding parts of triangles and to use the third angles theorem. Okay, so corresponding parts are just the parts like, for instance, the angles that are congruent to one another in each of the triangles. And then the corresponding sides that go together are each of the sides that are equal to one another. So if you take a look at the middle here, and it has our corresponding angles, we have AD are congruent. We have angle B and angle E are congruent. And then we have angle C and angle F are congruent. So notice that we're actually comparing one angle from one triangle and one angle on the other. Alright, so each of the corresponding angles are congruent. And you notice that they are also marked by different art marks. So A and D are marked with one art mark. C and F are marked with 2. And B and E are marked with 3. And you can tell that they go together because of the number of art marks they have. Same thing for corresponding sides. If you notice, BC actually has one mark, and so does EF. Okay, and you have to make sure that you actually say them in order. Notice how we said our blue letters first, then our green letters, and then blue letters, and then green letters. You don't want to switch them because that you won't be staying consistent. Okay. So basically, corresponding angles and corresponding sides are the ones that are congruent to one another. Just make sure that you are staying consistent. If you take a look at the bottom of the page down here, we have triangles that are being, first this is being reflected. Okay, and then as you see as we go through, we have one that's reflected here, and then reflected along this line, and then this one's just reflected from ABC over here. But you notice that even though we flip it, they're all still the same triangle. They're all congruent. Okay. Alright, couple theorems you're going to need to know. Don't forget your reflexive, your symmetric, and transitive properties. We use those in proofs in chapter 2. They're coming back here in triangle congruence. And also we have a new theorem called the third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. Okay, so for instance, if B was 60 degrees and we have A was 59 degrees, and we see that E has this one art mark, so we know it has to be 60 degrees, and D has two art marks, so it has to be 59 degrees. If you add those two together, you get 60 plus 59, which is 119, and then if you took 180 minus 119, you would get 61. You would get 61 degrees. So that means this third angle has to be 61. Well, you see that we have 60 and 59 as well, so we know the third angle has to be 61 as well. So instead of having to do that every single time, we just know that the third angles theorem. All right, let's try some examples. In the figure, ABCD is congruent to EFGH. First off, I want to point out to you that this is a congruent statement. Okay, that means that A goes with E, B is congruent to F, C is congruent to H, and D is congruent. C is congruent to G, and D is congruent to H. Okay, it's very, very important that you can stay consistent and you go in the same order. Okay, identify all pairs of congruent corresponding parts, then write another congruent statement for the polygons. Okay. So, if we look at this congruent statement, the first angles are going to go together, A and E. And if you notice on our picture, A and E actually have 4 art marks. Okay, so A is congruent to angle E. Okay. Second letters, angle B is congruent to angle F. Third letters go together, so angle C is congruent to angle G, and D goes with H. Angle D is congruent to angle H. Okay. We needed to find all congruent corresponding parts, so that means we also need to look at our sides as well. Okay, if you actually look at your congruent statement, we have AB first, and then we have EF first. So we know AB is congruent to EF. Okay, and you can do that looking at your congruent statement all day long, or you can take a look at the picture. Okay, we just did AB, so we went from 4 arc marks to 1 arc mark, and then we looked at the second picture, and we went to 4 arc marks to 1 arc mark. Okay, so that's where we got our EF from. Okay, let's see, we have AD, so we went to 4 to 3 arc marks, so we're going to go from 4 to 3 here to get EH, so AD is congruent to EH. Okay, alright, let's look at CD, so I just said 2 to 3, and so that would be GH over here, and that's 2 to 3, staying consistent. Okay, so we have CD is congruent to GH, and the last one, of course, is BC. So we went from 1 arc mark to 2 arc marks. So here we'll go from F to G, going from 1 arc mark to 2 arc marks. Okay, so BC is congruent to FG. Okay, and then the last part, we needed to write a different congruent statement. So I'm just going to take a look at my angles over here. Notice my original congruent statement was A, B, C, D is congruent to E, F, G, H. So I'm just going to start at the bottom, okay, and then come around up to the top. So I can say D, A, B, C is congruent to H, E, F, G. And there's more than one way you can rewrite this congruent statement. Alright, next example. In the figure, triangle LMN is congruent to RST. Find the values of X and Y. Alright, so just looking at our congruent statement, we know which angles are congruent to one another. L is congruent to R. M is congruent to S. And we know that N is congruent to T. Okay, well, first off, I know that M and S are congruent, so I know that this is 93 degrees. I know that R is congruent to L, so I know that this is 3x as well. Okay, and that also means that ML and SR are congruent. So I can set 3x plus y equal to 43. And I'll also know that if I add up all my angles in a triangle, they equal 180. So I can set that up as 3x plus 93 plus 63 equals 180 degrees. Okay, and then you want to solve for the equation that has only one variable in it. So if you do 93 plus 63, you get 156, so 3x plus 156 is equal to 180. Subtract 156 on both sides. You get 3x is equal to 24. And then, of course, divide by 3 on both sides, and you get x equals 8. Okay, so we know that x equals 8. Now I need to plug that in for x over here. So we have 3 times 8, which is 24, plus y equals 43. Subtract 24 on both sides. and we get y is equal to 43 minus 24, which is 19. And there's my two answers. And number 3, we need to show that the quadrilaterals are congruent. Okay, that means all corresponding parts are congruent. Okay, so that means all the sides need to be marked that are congruent, and we need all the angles. Well, if we take a look at this picture, we see that all the sides are marked, and we know that all those are going to be congruent. So we have to take a look at the angles. Now, the only thing is that we're missing these two angles. But if you notice, we have two intersecting lines, and that means that these are vertical angles. So angle KLQ is congruent to angle MLP because they're vertical angles. Okay, and now that we have shown that all corresponding parts are congruent, therefore all the two quadrilaterals are congruent. Example 4, we need to find the measure of angle T and explain our reasoning. Okay, well, again, if we find this third angle here, all we have to do is add 74 plus 41 and find C. And then here, you see that R is congruent to A because we have our one arc mark. And we know that B is congruent to S because of their two arc marks. I'm going to put this in a different color. Okay, so we see their two arc marks. Well, by the third angles theorem, angle C and angle T are going to be congruent. Okay, so we actually have a reasoning. Now we just need to find it. So to find the third angle in a triangle, you take your two angles, 74 plus 41. Okay, you get 115, and then you take 180 minus 115, and we get 65. Therefore, angle T is equal to 65 degrees. And we explain that by the third angles theorem. Okay. All right, last example we're going to do. It says the congruent statements triangle ABC is congruent to triangle DEF, and triangle ABC is congruent to triangle EFD. And we know that triangle ABC is congruent to triangle FDE are all valid. And we want to know what must be true about triangle ABC and DEF. Alright, so I don't know about you, but I can't just look at it and understand it. I need to actually draw it out. So triangle A, B, C, and triangle D, E, F. And I know by a congruent statement, I know which angles go together. So A and D are going to be congruent. B and E. And then C and F. Okay. Then let's take a look at the next triangle statement. ABC and EFD. So I'll do EFD. Alright, so that means A and E. That means B and F. And C and D are all congruent. And ABC, FDE. Okay, so FDE. Okay, so that means A is congruent to F, B is congruent to D, C is congruent to E. Alright, so let's actually just take a look at the red angles real quick. We have A is congruent to D, E, and F in all four of those triangles. Well, if A is congruent to all three of the angles in this one triangle, so D, E, and F, A is congruent to all three of those, that means that each of these angles are equal to one another. So if we take 180 divided by 3, that means all angles are 60 degrees. Or they're equilateral triangles or equal angular. Okay, and that's it. All right, have a great day.